Now let's talk about the deviation from ideal gas behavior. Remember, gases can be real or can be ideal. So let's talk about it. As I mentioned, gases by right is not real, ideal at all. They are all real, right? Now, so what do you mean by real gas? Okay, how can it be assumed to be an ideal gas? All right, is most likely an ideal gas at this condition. What is it? Number one, low pressure. All these will come out, and these are your marks. Very easy. Because when it's a low pressure, the gas molecules are widely spread apart, right? Because you don't pressurize them, so the molecules are very far apart. And thus have negligible size or volume. Why? Because the volume occupied by the gas is very large compared to the gas molecules itself. Do you understand what this statement means in the first place? Most people don't. Ladies and gentlemen, if in my room, these are the gas particles, all right? So let me just draw it out, okay? So let's just draw it out, say something like that, okay? And where are my gas particles, all right? The gas particles, low pressure is a low pressure. So low pressure means they are very what? They are very far apart. Agree? Make sense, huh? So in this room, if I fart, I will ask you what is the volume of my fart in my room. Okay? The volume will therefore be this volume. In 3D, let's say it's like that. If not 2D, is in meter square, this meter cube, right? So let's just use 2D, easier to see. All right. So this is the volume of the gas, or volume occupied by the gas, which is a big volume. However, take a look at the gas molecules itself. The mass molecules is very, very small at a certain space. Is it okay? Now, let me be more precise. That is the room, right? I don't like it. Let me scrutinize it further. Okay, I think it's easier. So that was the room, right? So let me remove the room. Okay, let me remove the room. So I'll say what is the relative amount of volume occupied by the space. If you look at it, right, it's like it takes a lot of space, but in that space, which is what is the space? This is the volume. Am I okay? The amount of gas volume taken up is just this one, very small, tiny. If you calculate the volume, it's okay. And compared to the whole space they take up around them at low pressure. Then let's say it's a high pressure. What will happen, right? So this is at low pressure. Take a look. This is low P. Then you say, Mr. Chua, what about high P? High P, then the particles going to be all very close to each other. Make sense? So I'm going to measure again a certain space taken up by the gas. If you look at it, let's say I draw about the same space. Can you see? So the volume occupied by the gas is still about the same. However, this time around, there is what? The volume of the gas particles are not negligible anymore. Can you see? Because they're not widely spread apart. All right, so this is when it's high P. And at the same time, at low pressure, you got some problem, is that the forces of attraction between the gas molecules at low pressure, forces of attraction are virtually zero because they're very far apart. They got no chance to do IMF between each other. So this take care of the first assumption and the second assumption. All right, at low pressure, whereby we say it has negligible size of volume. We also say the IMF is negligible. At high pressure, then what happened? A high temperature, sorry, the next factor. All right, you have negligible intermolecular attraction. Why? Because when you have high temperature, loss of energy. What energy? Kinetic particle energy. So gas molecules have sufficient kinetic energy to overcome the IMF. So this take care of factor number 2 once again, the second assumption. All right, all in all, a gas is most ideal at low pressure and high temperature. Okay, so here we go. So it's a repeat over here. So real gas, most gas are real because they will definitely deviate from the ideal gas behavior because the two basic assumptions are definitely not true. Because number one, a real gas will always have significant size and volume. Number two, there will always be IMF between them. All right. So you will show the greatest deviation from ideality at where? Right. Once again, it's a repeat at high pressure. Because gas molecules are packed closely together and size of the gas molecules cannot be assumed to be negligible anymore. As well as low temperature, because the kinetic energy is pretty low, thus forces or IMF between the gases are very significant. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.